Hey guys, welcome back. So in this today's session we are going to see about the flow control mechanism in the data link layer. So data link layer is nothing but the layer 2 in the OSI model. So the main functionality of the data link layer is framings, right? So data link layer is responsible for moving the frames from the one node to the another node. So what is the meaning of this one is, suppose for example you consider any networking scenario. So from your PC, if you want to send the information to the another PC, so in between that we will be having the multiple switches as well as the multiple routers, right? So now what we have to do is we need to route the information from the one node to the, suppose for example this is one node to the another node. So what is the duty of the data link layer is that it is going to send the frames from the one node to the another node. This is the one of the function or operation of the data link layer. So then one more function of the data link layer is it is going to perform the flow control operation as well as the error control operation, right? So flow control will determine the what is the maximum amount of data we can send from the transmitter to the receiver. So what is the need of performing the error control operation means, if somehow the data which is lost at the receiver side, so if you want to get the same data again, if you are implementing the error control operation, then we can ask for the retransmission of the data from the transmitter side. So the agenda of the today's class is to learn about the flow control operation in the data link layer, right? So there are two main protocols, right? So in the data link layer, so first one is the for noiseless channel and second one is the for noisy channel. So first we will see that why we have the two classifications. One is noiseless, another one is the noisy channel mechanism. Once it is done, we will see what are the different type of protocol we will be having in case of noisy channel as well as the noiseless channels. Suppose for example you will have the something sender information as the receiver information. So from this, now if you observe here, so the transmission from the sender to receiver, the data frames will be takes place. Now there are two kind of scenario. So here the communication channel. So whatever the data that you are sending, so data or frame you are sending from the sender to receiver, there will be no chance of getting the last of the data at the receiver. It means that this kind of channel we called as the noiseless channel, right? So noiseless channel we called as the this particular operation. So here where the channel is assumed that the channel will carry the whatever the data which is sending by the sender will absolutely reached by the receiver without any error. So it means that there will be no noise, no interruption during the communication process. So under this we have the two protocols. One is called as the simplest protocol, another one is called as the stop and wait protocol. So this is nothing but, so this is what we called as the error free channel. It means that there will be no loss of the information from the transmitter to the receiver in case of the noiseless channel. So again we have the one more protocol called as the noisy channel. It means that it is also called as the error creating channel, right? So what is the meaning of error creating channel means, if we are sending the information or frame from the sender to the receiver, there is no guarantee of the delivering of the packet at the receiver. It means that the packet may be received, the packet may be lost. There are two kinds of possibilities will occur. Why the packet will be lost? The reason is that it is error creating channel or it is the noisy channel. It means that you cannot able to expect 100% of the packet will be delivered to the receiver. So under this we have the three kinds of subcategories of the protocols. The first one is stop and wait. Later on we will see that what is the meaning of stop, wait, and what is the meaning of the ARQ. So one more is the go back N ARQ, then final one is the selective repeat ARQ, right? So based on this channel we have the two, one is noiseless, another one is the noisy channel. So in this today's class we will try to complete the what are the two different protocols of the noiseless channel. The first one is the simplest protocol and second one is the stop and wait protocol. Now we will see that how simplest protocol will be work in case of the noiseless channel, right? So here one point to be remember is that here the channel is assumed that there will be no frames are lost or corrupted or duplicated. So whatever the frame you are sending from the sender to the receiver, each frame will be received to the receiver successfully, right? So the protocol does not implemented the error control in the category. Now what is the meaning of this one? Why there is no error control mechanism or why there is no flow control mechanism means, suppose if you are sending the information from sender to the receiver or transmitter to the receiver, so here we are going to send at a time only one frame. If you observe here, at any point of the time we are going to send only one frame, right? So what is the meaning of flow control mechanism? How many maximum number of the frames that we can send from the transmitter to receiver before receiving the acknowledgement, right? Suppose for example, here the capacity is something you can consider as the bucket. So here it can able to take the 3 packets at a time. Now how many packets we can able to send from the transmitter? We can able to send the 3 packets at a time, right? Because this is the capacity of the receiver. Now see that here at any point of the time we are sending only one frame at a time. It means that we are not going to send the based on the capacity of the receiver. So it means that if you are not going to calculate the what is the maximum amount of the packet that you can send from the transmitter to the receiver, then there is no requirement of the flow control mechanism. Why? At any point of time we are sending only one frame. It means that we are not going to calculate the what are the maximum number of frames that we can able to send from the transmitter to receiver. It means that it is not required to perform the flow control operation. Now there is no requirement of the error control operation. So it means that what the thing we are assuming that whatever the data we are sending, everything will reach it to the receiver without any lost or corrupting or duplicated the data. So it means that we don't require something called as the error control operation. Now we will see that what is the operation of the simplest protocol. See that here we have the sender side, here we have the receiver side. So if you observe here, the first time from the sender to the receiver, so what we are going to do is we are going to send the first frame, right? So we are going to something called as the frame 1. So we are thinking that the sender is assuming that always the frame will be reached to the successfully at the receiver side. So after some time it is going to send the one more frame, after some time it is going to send the one more frame. So this is the operation of the simplest protocol. The main important point is that here no flow control as well as the error control operation will not be performed. Now we will see the next protocol is the stop and wait protocol. So what is the meaning of stop and wait protocol means, here we have the sender side operation, at the same time we have the receiver side operation. So what is the assumption here we are using at the sender side means, the first time sender has to send the one data packet at a time. It means that it has to send only one data packet. It means that we are not going to find the what is the capacity of the receiver. It means that we don't require something called as the flow control operation. It means that we are not going to calculate the capacity. So for that reason we don't have the flow control operation in the stop and wait protocol also. Now see that at any point of the time the maximum frames or packets we can able to send only one data packet or one data frame. Then the main important point is that sender will send the next packet only when it receives the acknowledgement of the previous packet. So what is the duty of the sender side? It will send the packet, first packet it will send, before if it is want to send the second packet, now it should get the acknowledgement from the receiver. If it is not getting the acknowledgement, then there is no way to send the one more packet. This is the rule at the sender side operation in case of the stop and wait protocol. If you observe here, what is the meaning of this one is, first you send one frame from the transmitter to the receiver, right? Then you stop the process, right? So then you wait for until the acknowledgement received from the receiver. Once if you get the acknowledgement from the receiver, then again you go ahead with the one more frame. That is the meaning of the stop, then wait. After receiving the acknowledgement, again you send the one more frame. That is the meaning of this one. Now we will see that what is the receiver side operation, right? So the duty of the receiver is that receives the data packet sent by the sender. So it will receive the packet which is sent by the sender side. Now when the data packet is received, now what it has to do, the receiver should send the acknowledgement to the sender, right? So this is the duty of the receiver. So this is the important point to be remembered. At a time we can send only one data packet, and after receiving the acknowledgement only we need to send next data packet. If you are not getting any acknowledgement, then there is no way of sending the one more data packet or frame from the sender to the receiver. So this is the what operation which is used in the stop and wait protocol, right? Now we'll see that what is the limitation of the stop and wait protocol. So for that, what is the methodologies we are using in order to overcome the problems which is created in the stop and wait protocol, right? Now for example, what is the first limitation is that if you see here in stop and wait protocol, at a time it is sending only how many data frames? At a time only one frame, right? Suppose for example you consider this is the sender, this is the receiver, right? So the bandwidth something like this. If you have a bandwidth that can carry 100 frames, it means that at a time there is a possibility of the sending the 100 frames at a time. Now what we are doing here in this case of stop and wait protocol, from sender to the receiver, we are going to send the one frame at a time. For example, here we can able to send the, so in that bucket or receiver side, it can able to receive the 100 frames. The maximum capacity is something like this. But any point of time we are sending only one frame, right? Let it be from reaching to the transmitter to the receiver, let it be 1 second time period. Now see that for the second time period we are sending the one more frame, for third second we are sending the one more frame, for fourth second we are sending the one more frame. It means that to send the 100 frames we require how many time? We require the 100 seconds. But if you are using the bandwidth effectively, it means that within 1 second period you can send the 100 frames at a time. So this is what one of the limitation of the stop and wait protocol, where instead of sending the multiple data frames at any point of time we are going to send only one data frame, right? So this is the one of the limitation of the stop and wait protocol. Now we will see the what is the problem, right? So next problem is that the problem is occurs due to the lost data, right? As we know that rule from the sender to receiver is that the sender has to send the packet and it should wait for the acknowledgement, right? If it is not getting the acknowledgement back, then it should not able to send one more frame, right? That is the duty of the sender. Now here we will consider the scenario. This is my sender side operation, this is my receiver side operation. So I am going to send the data from the transmitter to the receiver. Somehow in communication medium in between sender to receiver, the data is lost, right? Now if you try to assume, right, if you make a assumption, now what sender will think here is that I have sent the packet, right? So it means that sender will assume that I have sent the packet from the sender to the receiver. Now what sender will assume that I am waiting for the acknowledgement from the receiver. Now what receiver will think is that I didn't receive any packet, so that I cannot able to send the acknowledgement back to the sender side or transmitter side. It means that if you observe here, sender will wait for the infinite amount of the time period, right? So if it is want to send the next data frame, it has to get the acknowledgement, right? So in communication somehow the data is lost. So sender will wait for the infinite amount of the time period, right? If it is want to send the one more frame, it has to wait for the acknowledgement. In the same way, the receiver also will wait for the infinite of the time period. When receiver will send the acknowledgement? After receiving the data only, right? Data frame only, right? So receiver also will wait for the infinite time period. Now here what is going to happen means there is no further process will be run. So that is one of the limitation if your data is lost in between sender to the receiver, right? So see that sender waits for an infinite amount of the time for an acknowledgement, receiver wait for an infinite amount of the time for the data. This is one of the limitation of the stop and wait protocol, right? Now we will see that what is the one more problem. Suppose for example see that what is the meaning of the last acknowledgement. Now if you observe here, so here we have the sender side operation as well as the receiver side operation. Now for example, first it sends some data, nothing but the frame 1 has been sent from the sender to the receiver. Now what sender will do? Sender will wait for the acknowledgement from the receiver, right, in order to send the one more frame. Now see that after receiving the particular frame by the receiver, then what receiver is doing means receiver is sending the acknowledgement back. Now due to somehow what is happening in between transmitter to receiver, the acknowledgement is lost. Now what receiver will feel that I have sent the acknowledgement back to the sender, so now I am ready to receive the packet, but I am waiting for the sender to send the packet. Now what sender will think is that I have sent the data, I am waiting for the acknowledgement. If the moment when acknowledgement is sent by the receiver, I will be receiving that acknowledgement, so that I am going to send the one more frame to the receiver. Now in this case also, both sender as well as the receiver is waiting for the infinite of the time period. So it means that the process will be stop here itself without sending the any further data, right? So this is the major limitation of the stop and wait protocol. So what is the meaning of stop and wait protocol? The meaning is that first you send one frame, then wait for the acknowledgement. After receiving the acknowledgement only, then only you are eligible for sending the one more frame. Now what is the first limitation? So poor bandwidth utilization, right? So poor bandwidth utilization. What is the meaning of this one is, even though if you have the capacity to send the 10 frames at a time, if you are sending only one frame at a time, so it means that this is one of the limitation, right? So this is one of the limitation, poor utilization of the bandwidth, right? So second one, in between your communication, if data is lost, then transmitter will wait for the infinite of the time period, then receiver also will wait for the infinite of the time period. Then one more problem is that if the transmitter send the information to the receiver, suppose for frame is transmitted, now receiver is sending the acknowledgement, somehow this acknowledgement is lost in between the transmitter to the receiver. Now in this case also, transmitter will wait for the infinite of the time period, receiver also will wait for the infinite of the time period, right? This is what we called as the last acknowledgement. So to overcome this problem, we are going to implement some other protocol called as the stop and wait ARQ, right? So what is the limitation of this one? At a time we can send only one frame. That is what one of the limitation, poor utilization of the bandwidth. If data is lost, then both sender receiver will wait for the infinite of the time period. If acknowledgement lost also, both sender and receiver will wait for the infinite of the time period. So this is the drawback of the stop and wait protocols. For this solution, we are going to implement something called as the stop and wait ARQ protocol. In the next class, we will try to see how stop and wait ARQ protocol is differ from the stop and wait protocol. I hope you understand. Thank you guys.